Hey, welcome. So you're prepping for a data warehouse interview. I get it. The whole process can feel a little intimidating. The goal here is to arm you with the concepts, the frameworks, and honestly, the confidence you need to absolutely ace it. So let's just dive right in. All right, so we've structured this to cover pretty much all the bases you're going to face. We'll kick things off with the fundamental concepts, then jump into a practical design scenario. After that, we'll tackle some crisis management questions, check out modern cloud tools, and wrap it all up with a deep dive into SQL optimization. Okay, first things first, the fundamentals. It doesn't matter what your seniority level is, every interview starts right here. A solid foundation just shows that you really, truly know your stuff. So let's make sure that foundation is rock solid. So at its core, what is a data warehouse? You can think of it as the single source of truth. It pulls together data from all the different corners of a business into one central spot, and it's built specifically for analysis and reporting. This gives the company a complete historical view of all its data. Now, this is a big one, the difference between OLAP and OLTP. I'm telling you, interviewers love to ask about this. Here's the key takeaway. OLTP systems run the day-to-day operations of the company. Think processing and order. They're built for fast, simple transactions. OLAP systems, on the other hand, are all about analyzing the business. They run complex queries over massive sets of data to find trends and insights. And when you're building that OLAP system, you're going to use a schema. The two big ones are star and Snowflake. A star schema is simple and super fast for queries because it's denormalized. Basically, it intentionally duplicates some data to avoid complex joins. But the trade-off is that it uses more storage. A Snowflake schema, on the other hand, normalizes everything. It breaks out tables to reduce redundant data and save space. But that adds complexity, which can mean more joins and slower queries. The right choice, it always comes down to the specific use case. Okay, let's see how all these concepts actually fit together. It's time to take the theory and put it into practice. A really common interview tactic is for them to give you a real-world scenario, and e-commerce is the classic example. So the interviewer leans in and says, okay, you've just been hired to build a data warehouse for a major online retailer. Walk me through your process, step by step. How do you respond? Well, you do it by laying out a clear, structured plan. And this slide basically lays out that exact plan. You start with the business requirements, what are the key KPIs, then you model the data, most likely using a star schema for something like sales. You pick your tech stack, design your ETL, that's extract, transform, load, or ELT processes to actually get the data in, and finally you plan for performance optimization right from the very beginning. A framework like this shows you can handle the whole end-to-end design. All right, now for the fun part. What happens when things go wrong? Your ability to problem solve under pressure is a huge indicator of your experience. So let's walk through a couple of common crisis scenarios. It's Black Friday, and your data volume just exploded. The system is grinding to a halt. What's your move? This question is all about testing your understanding of scalability. Your answer here needs to be multi-pronged. First, you scale the infrastructure, add more compute power. Then, you look at your database architecture. Can you partition the huge tables? By that I mean, can you break them into smaller, more manageable chunks based on something like a date key? Next, you optimize your ETL jobs to handle the load more efficiently. And finally, you'd work with the analysts to tune any heavy-hitting queries that are bogging down the system. Here's another classic problem. A stakeholder comes to you and says, hey, the sales numbers on this dashboard don't match what we're seeing in the source system. Time to panic? Nope, you've got a process for this. You want to approach this methodically. First, trace the data backward through the pipeline to find where the error crept in. You'll validate it against the source system. Then you fix the root cause, which is probably in your transformation logic. Critically, you communicate the issue and the fix to your stakeholders. And to make sure it doesn't happen again, you add automated data validation checks. And that leads us perfectly into the modern data stack. Today, most data warehousing is happening in the cloud, and you absolutely need to know the big players and what makes their architectures unique. Let's compare two of the giants, Snowflake and Google BigQuery. The key thing to understand is their architecture. Snowflake gives you incredible flexibility by separating compute and storage. BigQuery, on the other hand, is serverless, so it handles all that resource allocation for you. This difference impacts everything, from the pricing model, which is usage-based versus data processed, all the way to unique features like Snowflake's time travel or BigQuery's built-in ML capabilities. All right, for our last section, we're going to get our hands dirty with some SQL. Because let's be honest, a beautifully designed warehouse is useless if the queries are just too slow to run. This is such a fundamental practical skill. An analyst comes to you complaining that their query has been running for an hour. This isn't just some hypothetical question. For a lot of data pros, this is a daily reality. So how do you tackle it? You start by analyzing the query's execution plan. The explain command is your best friend here. It's going to tell you exactly where the bottlenecks are. From there, you might rewrite the query to use more efficient joins, maybe apply partitioning so it scans less data. Or, if it's a query that gets run all the time, you could create a materialized view. That's basically a table that pre-computes and stores the results, so you don't have to run the heavy calculation every single time. Here's a classic example of an inefficient query. Using a subquery within on a massive table can be incredibly slow, because the database might end up having to scan the entire sales table. And the fix here is surprisingly simple, but so powerful. By rewriting it as a join, we're letting the database's query optimizer choose a much more efficient way to get the same result. And that simple change, it can mean the difference between a query taking an hour and taking just a few seconds. So, to bring it all together, know your fundamentals inside and out. When you talk about your experience, structure your answers using the STAR method. That's situation, task, action, and result. Practice your SQL. And remember, an interview is a two-way street. Make sure you ask them thoughtful questions about their challenges and their tech stack. This quote from the source article really nails it. Remember, the person interviewing you has been on your side of the table before. They just want to see how you think and how you solve problems. Being well prepared is the key to showing them the best version of yourself. And we'll leave you with this final thought. Beyond just the technical questions, be ready to talk about what's next. Whether it's the rise of the data lakehouse, real-time analytics, or AI integration, having a point of view shows you're not just qualified for the job today, you're thinking about tomorrow. Thanks for tuning in.